Hello, my name is Jeremiah Rhodes, and I'm a master's student studying environmental science at the University of Tennessee at Chattanooga. Today, Anna Marie and I will be summarizing some key points from Gadskar's fine seminar on the direct fitness options of Indian wasps. So a fundamental feature of eusocial insects like ants, bees, and wasps are reproductive castes, with a reproductive queen and non-reproductive workers. Because they are non-reproductive workers, there are questions about their fitness. These workers spend time working for the colony but are not reproductive, and this brings in the paradox of altruism. How does natural selection favor the evolution of such altruistic workers? Shouldn't natural selection just get rid of them? Hamilton's rule states that an altruistic behavior will evolve if the benefits to the recipient, multiplied by the relatedness between the actor and the recipient, exceeds the cost to the actor. In other words, an individual will be more likely to engage in an altruistic behavior if the benefits to the recipient are greater than the cost to the actor, and if the recipient is closely related to the actor. Hamilton defines fitness as the direct component and your indirect component, with your direct component relating more to Darwin's fitness as your reproductive success and your indirect relating to caring for your genetic relatives. In primitive eusocial insects, caste differentiation is actually regulated socially compared to developmentally regulated in other eusocial insects. So this means that a role an insect plays within a colony is not determined genetically, but by its environment and social cues. This is likely an adaptation that evolved because it increases the colony's ability to survive and reproduce. When looking at indirect fitness, the genetic relatedness between individuals was low. So that means that workers should be looking for opportunities to increase their direct fitness. Indirect fitness may be an inadequate driver to social evolution when worker-queen genetic relatedness is low, as seen in this column to the right. Direct fitness is necessary for the evolution of social behavior in the Indian wasps. The possibility of direct fitness has usually been ignored in some primitively eusocial species, and since direct fitness is likely the driver of social behaviors, Gadskar's lab studies the direct fitness of primitive eusocial Indian paper wasps, and there are two ways workers can receive direct fitness benefits, with the first being from nest foundations. In voluntary nest foundation experiments, Gadskar's lab observed 29 new nests were formed from 9 parent nests. These wasps formed pre-foundation aggregations away from their original nests, where they fed and engaged in dominance relationships. They found some unusual behaviors from the wasps, like the wasps congregated outside their parent's nest and showed dominant and subordinate interactions before initiating multiple foundress nests. And they also found the most dominant wasps of such aggregations always became the queen. These created observations that led to other studies done by Gadskar and his lab. In involuntary nest formations, groups of 1, 2, or 3 wasps were put together in experimental chambers where their behaviors were studied. They found the emergence of cooperation and the division of labor if there were 2 wasps together. In the experiments with 3 wasps, there continued to be high levels of cooperation and division of labor, but also the emergence of a queen. One wasp became the queen, while one other one became reproductive, and the last became non-reproductive. This leads to an increase in productivity as well as division of labor and cooperation, and this can be seen through the models and the mean of the experiment, with the red equaling 3 wasps in the model in the experimental, and then 2 is blue and 1 is green. And now Anna Maria will be discussing direct fitness through queen succession.
Thank you, Jeremiah. Hi, my name is Ana María Romero. I am a biology undergraduate student at Universidad del Rosario in Bogotá, Colombia. Queen succession happens when workers overthrow existing queens and become new queens of their natal nests. Gadagkar observed that workers and queens were identical in physiology and can't change their roles. So they wanted to see if workers and queen had any behavioral differences. By calculating a time activity budget and a behavioral profile, they identified clear difference between sitters, foragers, and fighters. Surprisingly, queens were present in the sitters group, indicating that they are non-aggressive and docile. But how does she become a queen in the first place? Was it through pheromones? They removed the queen and reintegrated her to observe what happened to the colony while she wasn't there. While the queen was absent, one individual increased his aggression. This is the individual which becomes the next queen, and it's called potential queen. However, if the queen starts aggressive but then becomes docile, how does she inhibit the reproduction of workers? To answer, they repeated the same experiment but divided the nest in two. The queen, instead of being removed, it was transferred from one side to the other. They observed that the hormone is not valuable to inhibit reproduction of workers. Also, they observed that on the queenless side, there is always a potential queen. Looking a little deeper, when the queen is removed, there is only one aggressive individual. Can this individual be predicted? Although there was a lot of effort to answer this question, it is not possible because as long as the queen is there, it cannot be predicted. For example, the graph shows that workers and potential queens can't be differentiated. But do the wasps know who the queen successor would be? They modified the mesh experiment in a very interesting way. There are two possible cases in this experiment. One, the hair designate, which be the next queen, would be at the opposite side of the queen. She becomes the potential queen or PQ1 on her side, and then they exchange them. If she truly is the next queen, she would be accepted on the other half of the nest. However, their hair designate can be in the same half as the queen. What will happen on the other side? The most capable wasp would become PQ1, but when they got changed, PQ1 and their hair designate will be on the same side, so hair designate will become PQ2, the true next queen. When PQ2 is changed to the other side of the nest, she would be accepted by all the colony. So in fact, there is a hair designate. We as humans don't know which individual is, but wasps do know. If there is a hair designate, is there a long reproductive queue? To study that, they remove the queen, wait for PQ1 to emerge, and then remove it. They repeated this procedure 5 times, and there were 5 potential queens, meaning that there is a long reproductive queue. This fine seminar concludes that there is a behavioral mechanism that wasps develop to make direct fitness possible.